Hello, guys. My name is Desmond. A very warm welcome to my lesson for today, where we will be looking at your mathematics. So, ladies and gentlemen, as always, please do allow me to say very, very much important that I say it is very, very much important because what I'm about to say, Bosisi, way massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, Bantu Pagiti, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, very quickly, we will need to do corrections of the test that you guys wrote on Saturday. So, I just need a confirmation from someone if all is clear from your side. Can you clearly see? Can you clearly hear me when I speak? Yebo no maka.
Yes, sir, you're clear.
Okay, 100%. So I think at 8 o'clock, it's going to be load shedding on my side. So we are going to be very quick on this one. Obviously, you've gone through the given statement, the diagram, and the question. So I won't waste much of our precious time, but what I'm going to do is to quickly read and then we start with the questions. Only rise on a point of order in case if you do not understand what I've explained. So let's see, in the diagram below, A, where's A? Oh, there's A. Being that point, B, there's B, and D, there's D. Can you see? They didn't mention C. Possibly it's going to be there, but somehow they will introduce it. So A, B, C are the coordinates of the vertices of triangle A, B, D. And they say BD. Where's BD? There's B, there is D. Intersect the x-axis at E. Oh, okay. So that means there we've got E. And F. Where is F? Remember, guys, in case if I'm breaking, in case if it's blank, let me know immediately. Inclination, listen very carefully. The angle of inclination of BD, where is, oh, there's BD with the x-axis at E is alpha. Okay, no, it's alpha. The angle of inclination of AD, where is A? There's A, there's D with the x-axis at F is beta. Okay, so that means in terms of the angles, we've got alpha and beta. 5.1 calculate being that one and then x2 that and then that being that. Let's see. What is the answer for this one? Here says my calculator is far, but you guys will have to be so what? Let's see. Negative 6 over 4, which is what? 3 over 2. Is this the final answer that you guys got?
Yes, sir.
Hey,
Yes,
guys,
sir.
can you hear me? Okay. Yes, 100%. So this is where you give your mark for correct substitution and for your final answer. Remember, I think this question is out of 20. So you will say for question 5, whatever out of 20, and then for the next question, whatever out of whatever, and then last one, then we'll also do the total. So now let's maybe write it there to say which one. This is AD. This is the one which is negative 3 over 2. So very quickly, let's move on to the next question. So the next question, determine the length. Can you see? the length. They are not saying the distance. Determine the length of the line, segment AD. Where is there? It's A, there is D. Leave your answer in SAT form. When they say in SAT form, they mean leave it in a form of square root. Don't write it as a decimal. So we know that the length is the same as the distance, and this is the formula, which says, obviously, x2 minus x1 close squared plus minus y1 close squared. So let's see that. Maybe, let's say our x2 is this one, being 5 minus that one there being 1. And then what about this one? That, let's see, is 4. 4 squared is what? I think it's 16 plus this is negative 6 squared. What is negative 6 squared? Is it 32? Yes, my calculator is far.
36.
Guys, are you still there? Okay,
36.
36. So what is this plus that? Let's see, you take 4 there is 40, you take 10 is 50, then it's 52. I think it's 52. Am I correct with that one?
Yes.
Yes.
100%. So you give yourself for correct substitution, and then you give yourself for correct final answer. This one and the formula, no marks for those. So very quickly, let's move on to 5.3. Remember, guys, but these are the easy questions. I don't think you guys will be confused with those two. So let's see. The next question says determine the the coordinates of M, the midpoint of AD. So you guys see the midpoint. This is what they want you to provide. So you are allowed to write it in this manner. You say it's x1 plus x2 over 2, and then y1 plus that over that. I saw most of you guys got this one correct. This question. Let's see. X1, you can say is that 1 plus 5 over 2, and then that one there being 4 plus negative 2 inside the brackets because it's a negative. And then finally, you can give the midpoint of AD, which is going, what is this? Is 6. 6 divided by 2 is what? Is 3. This is what? This is 2 divided by 2 is 1. Yes, it makes sense because that point is above there and then it's on this side. So yes, 3 and 1, it makes sense. So let's see, where do you get marks? I'm telling you, they only give you a mark for the x value and also a mark for the y value. So that's how you score yourself marks for those. Now we are about to move on to the next question. So I am going to remove all of that. I'll only take a pause on those questions that I think are a bit challenging. But let's see. 5.4 C is a point such as that line BC, okay, line BC is parallel to AD. There's AD. So for you to have a parallel line, a line which is parallel to that, so somewhere there, that's where you might have that point C. Wherever that C is, that line BC, it just has to be parallel to that other line. And you do know very well what happens with a line. So let's of line BC in the form AX plus BA. Abo examiner bayayithanda idrama. Can you see how they want the format of that? But we do know very well, whether they go south, we move together. So now you do know very well that the general equation of a straight line is just y that plus C at 1 point. So let's see. I think we know something about this line. Since we know the gradient of that one, so that means also this line, it has the same gradient. So let's somehow just substitute it there and say this is it. At what point? Do we have any point on line B? Oh yes, there's a point because it lies on line BC. So that means we're going to say at point B, which is that and that. So let's substitute. We're having 1 negative 3 over 2. X it's negative 3. Actually, C is what we're trying. Okay, that times that, obviously positive. But what is 3? 3 times 3 is 9. I think it's 9 over 2. We still have that plus. So we take this to, okay, let's see. What is 1 minus 9 over 2? We get a negative value. So that means C is actually negative 7 over 2. So it's more like you end up having
Say you are cutting.
hey, let's uh, for 1 minute, I'm out of class and you guys are making noise already. Hey, Kwenzenjan, Kabelo Malit, can you hear me, honorable member? Is everything clear?
Yes, sir.
100. Okay, so this is the format in which they want your answer. So can you see? That means you just need to make sure that your x is attached to a certain value, and then your y is attached to a certain value, and you just have a number which is just a constant. So for you to rewrite this in that format, this is where now you can just multiply everything by a common factor, being that 2. So when you multiply everything by that 2, that times 2, and this one also, you multiply it by 2, and then this, you multiply it. So it's more like you end up having a, what is it? A 2y, which is equals to, that 2 is going to cancel. So you just have negative 3x. And then that 2 is, so you just have that. But let's maybe rewrite it in that format that they requested. So that means 0 is going to be on the left. So you move everything to the other side. Maybe let's start with that x. So that means we have a 3x, and then we have the one which has y being that, and then the other one we take it, so it becomes positive 7, and then they wanted 0 to be there. So I'm pretty much sure that it makes sense to everyone, unless if there's someone who's got a question on that. But I think most of you did get it up to a certain point, and then from there, you were fighting, Chem. You did fight, some of you guys. Um, but I can tell you, for you to know that the gradients are parallel, I'm going to give you a mark there, Bantibakiti. And then for you also to substitute that C value, I'm going to give you a mark. And lastly, for you to rewrite it in the format that I wanted you to write it, I'm also going to give you a mark. Any question on that one, or is it clear to all honorable members of Parliament?
Sir, I wanted to ask,
Yes. Mhm.
is it also correct if like I wrote it without multiplying by 2?
Then what is it that you have written? Hey,
So I did not multiply by the 2. So let me see. I
I understand, honorable member. You wrote positive 3 over that. Hey, yeah, wana ka be lo complicated dilo bjano. Ka be lo complicated dilo bjano. She wrote that as a fraction, and then what is it? She wrote y, and then she wrote a positive 2, 7 over 2, and say equals to 0, and she left it there. Ay, 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 ay. Kabza, o complicated dilo mo. No, I won't give you, honorable member. I won't give you a mark. I definitely won't give you a mark because this is almost the same format as that. You just rearranged everything, but I just want it in a format where you just give me that A value there, and then you give me that B value there and a constant. So it's more like, according to you, you are saying the A value is 3 over 2, the B value is 1, and then the C value it's 7 over 2. Whereas if we go to court, I'm telling you, magistrate is going to say, if your A is not 3, no bail. If your B is not 2, no bail. If your C is not 7, no bail. So can you see the kabza that here I'm telling you, you won't get a bail. Does it make sense, honorable member?
yes, sir.
Okay, so I'm going to check your script. Don't cheat. Give yourself a very nice 0 there, and give yourself 2 marks for that one. So now, very quickly, let's now move on to that other one. But I think most importantly, let's write this one. What was the okay? Gradient was the same. That over that x, and then this one was negative that. Okay, so it helps for you to have that info just in case you need it in future. So let's see, 5.5, 5.5.1, it says calculate the size of beta. This one, it has to be simple. You know, when angles are involved, you need to remember this formula. So that means already we know that beta is going to be equals to second function over the gradient. What is the gradient? It's negative 3 over 2. What is that answer there?
So isn't it 56,31?
56,31 there. Is it everyone who got that answer? Is this
Yes,
answer
sir.
correct?
Yes.
So this is our angle beta, ne? Honorable members.
Yes. I'm also got that, sir.
Okay, 100%. But remember, this is not beta. This is
Oh,
not
this
the
is
angle
it.
of inclination.
Yes, 180 minus that.
Yes. So this angle, it's actually that one. So be careful of that. Remember, you guys submitted. I know what you wrote, so you won't cheat. I remember. Just make sure that from there, that's when you can say angle beta, it's actually 180 degrees minus 56.31, which is equals to whatever that you got, which is 123.69 degrees. So that means this is that angle of inclination. Does it make sense to everyone? Can you see, guys, with these small mistakes, that's where you get it wrong, because you get a mark for correct substitution there, but here if you don't get to there, you don't give yourself a mark. But if you got that, then give yourself a mark, and you score 2 full marks there. So do we now move on to the next question, Bantu Bagiti?
Yeah.
Yes, sir.
Okay. In that case, I'm just going to quickly remove all of these. So let's see. Calculate all the angles of triangle D, D, E, F. D, E, F. They want those angles. I'm just not sure. Can someone give us a reason, or that reason which confirms that this angle is actually the same as that angle? This the same as that. Is there someone who remembers that?
So isn't it because of alternating angles?
Is it alternating angles?
Opposite, yeah.
Exterior angle.
Oh,
Someone is saying exterior angles. Okay, it's fine.
Vertically
yes,
So
opposite.
vertically opposites.
Yeah,
yes,
vertically
vertically
opposite.
something vertical, because you can see this angle is vertical to that, this one vertical there. So already we have this angle. How about since we know, what if we calculate alpha, and then whatever that we know that it's for us to get this angle, we can easily say 180 minus that angle. Let's maybe try to calculate that angle. Is there someone? Okay, no. I know there's no someone. Let's see. Obviously, for us to calculate that angle alpha, which is going to be the gradient of that line, let's see. Alpha will be equals to second function of tan, that gradient. Did we calculate the gradient of that line? I don't think we did, which means we might need to calculate it. Did we calculate it? I don't think so. I do not think so. So that means the first thing that we need to do is to calculate the gradient of this line. Why? Because I want to actually calculate the angle of inclination, that alpha. So let's see. We are going to have y2, of which you can say -2 minus y1 being 1 over x2 being 5 minus with that -3. Then what are you getting? I think here we get -3 over here we get +8. I'm not sure if you guys agree with me that the gradient of that line is actually a -3 over 8, which is what I'm going to substitute there. So guys, I'm moving at a very slower pace. In exam, you shouldn't be spending this much on answering these questions. Remember, you are not given time to think, but time to write. So what is this angle? Angle alpha. Let me see. Hey, malam. Vuga malamba. Vuga malamba. Hey, let's see. All right. A second function of -3 over 8. This is what I'm getting. I'm getting -20.56 degrees. So because of this negative, it means it's not an angle of inclination. It's this smallanyana angle here, which is -20, 20.56. But the one that I want is this one. So let's say 180 minus that angle. We are getting 159.44 degrees, which is this angle. But most importantly, even if you don't continue to calculate this part, you already know that, okay, this angle vertically opposite to this angle. So that means this angle also, it is 20.56 degrees, which is an angle that you actually wanted to calculate. So you might not need to do the 180 plus to get that alpha. I'm not sure if you guys understand before I continue. Does it make sense what I've done there to everyone?
No, sir.
Okay, let me quickly explain for my Leslie's there. Okay, let's say we have this thing, and let's say we calculate this angle. So, did you see, Leslie, the gradient of that one is negative what? Is it negative 5 over 8? Whatever that it was, we calculated this angle being alpha. And when we calculated that angle, we haven't got that angle, but we got negative 20.6, no, no, 56. So, Leslie, do you agree that this angle that we got is actually that one? Do you agree with this part?
Yes, sir.
So, remember, actually, what we want, the Leslies, we already know what this angle is there, which is 1, 2, 3. Let me just keep it simple and say we know this is 1, 2, 3. But the question wants us to calculate all the inside angles of this triangle. So that means we need to know what that angle is, what that angle is, what that angle is. So when we used the gradient of that line and we got a negative value, it means it's actually this angle that we got. And this angle is the same as this angle because of vertically whatever, whatever. So that's why I'm saying we don't need to really now say 180 degrees minus 20.56 because it is going to give us this angle and we don't really need that angle. But what we need is this inside angle so that we can say the sum of inside angles is equals to 180, meaning the angle of E, when you plus it with the angle of F and you plus it with the angle of D, they have to give you 180 degrees. You remember this thing which says the sum of interior angles of a triangle equals to that. I'm not sure. Does it make sense now, Leslie?
Yes, sir.
Okay. Does it make sense to everyone? Libandla la kaNkulunkulu.
Yes, sir.
Okay, 100%. So now that we have that angle, how do we calculate that angle? Obviously, if you know that angle E, you plus it with angle D, you plus it with angle F, it gives you 180 degrees. So that means you're going to say 180 degrees, it's equals to, no, no, okay, but it's fine. Let's say, what is angle E? We know is 20.56 degrees. You plus it with angle D. Angle D is what we're trying to, okay, plus that one being 123.69. So can you see angle D will be equals to 180 degrees minus this and that. What answer are you getting there?
35.75.
35.75. Is it everyone who's getting that answer?
Sir.
Yes. So let's see. So for that, I'll give you a mark. For that, I'll give you a mark. But remember, if you don't calculate it up to this point, you must state a reason. You say this angle, it is that one, and then vertically whatever, whatever. So that's where you will score 2 marks. But if you worked it up to here, you will get a mark for that. And then also for this one, you will get a mark. Let's see. It has to be 3 angles. Where's the other angle? We have this angle. We have that one. We also have which one? Oh, wait. This is angle number 1. Where's angle number 2? Oh, yes, is this one of 20 point something. You also have this angle. And then, what is it? We also give you a mark there for the ground. Yes. So If you manage to get all these three angles, then you give yourself a full marks on that one. Did you guys get it?
No.
So let me maybe do it this way. If you got your gradient to be that -3/8, give yourself a mark. If you calculated this angle of 159.44, give yourself a mark. If you got that angle of 20.56, give yourself a mark. And then that one of 123.69, a mark. And then this one for 5.75, give yourself a mark. Does it make sense now?
Sorry, sir. I'd like to ask if they care about the reasoning. Must also write the reason why.
Let's say, you see, if in that case you did not say 180 minus that's when you might score a mark for you providing a reason which you provided because you didn't want to calculate this. But if you did all of this and you gave a reason, hey, no Black Friday, unfortunately. So there won't be any parcela, honorable member, for that good reason. Make sense?
Thank you, sir.
Okay, 100%. Very quickly, let's move on to the other question. Okay, determine the equation. Determine the equation of a circle. Remember, every time you think of a circle, then you just need to remember this formula, theorem of Pythagoras. That's how I always remember this formula. We have y minus b there close squared is equals to r squared. These are the centers. So they are saying which passes through the points A and D. Give your answer in this form. Remember, this circle, it has a center at M. It's there. Determine the equation of a circle with center M passing through points A and D. Where is A? There is D. There is okay. So that means we can just say we have a circle similar to that. This is just an estimation. And then now having a center there. So every time when they say calculate or determine an equation, they're simply saying on this type of an equation, just find everything and leave your equation in a form of having letters X and Y only. So that means you're going to say X minus what is our X value of the center. So that means this is A and B. What is A? I think A, we calculated it to be what? Was it 1? I think it was 1. Y minus, what was B? I think B was 3. Was it not 3? No. X being the A, I think this is the one which was 3. And then this one is the one which was Y. I'm not sure if you guys remember. Do you guys remember?
No, wasn't B2 because
Maybe it
give
was
me
2.
BY.
Wait, B is Y, yes, and then A is the X value. But for M, when we were calculating the midpoint, what values did we get for M?
3 and 1, sir.
3 and 1. So that means X is 3 and then B is 1. I'm not sure if it makes sense to everyone, or am I doing it
Yes, sir. I see my
incorrectly?
mistake. Yes, no, sir. I see my mistake.
Oh, okay. So let's see. Now you are therefore going to say at a point. Which point would you like to use between this one? Maybe let's use A because it doesn't have those negatives.
Dumela.
Moleboge, yes.
Sorry, ke gona ke tsenang, I'm late. Ne ke kopa o ntlhalosetse from mo mathomong mo from the first step ya teng.
This one.
A ke re yeah, it kopa o nthomele yone mo mathomong eo yotlhe mo mathomong.
Okay, so at all the times, this is the standard equation or the standard formula of a circle. Every circle has this, and then A and B, it refers to the coordinates at the center of the circle. So if you have a circle, at the center, the coordinates are A and B. So we calculated that point being the center, and the coordinates was 3 and 1. So that is why there we are substituting 3 and 1. I'm not sure if you get it, Moleboga.
No, I get it.
Yes, then remember, they want you to determine an equation of a circle, and you need to find everything and leave only x and y. So that's why we need 1 point. So let's use point A. I think someone can still use point B and still get this. Okay, let's see. Ax is 1, so it's more like 1 minus 3 squared. What is y? Y is 4 minus that 1 squared. So we're actually looking for r squared. Or yes, r squared, because can you see here they're saying leave it as that and r squared. So that means this is, what is this? This is negative 2. It's obviously 4 plus, what is this? Is 9, I think. So what is, I think this is 13. So it's more like r squared is equals to 13. So you can somewhere say the equation is x minus the center squared plus y minus that center squared is equals to 13. And then this is it. I'm not sure if it makes sense to everyone, Bantu Bakiti.
It does make sense.
Okay, 100%.
Sir,
So, yebo.
it does make sense, right? But I want to know
Mhm.
because we said 13 is equals to r squared, so there's no need for you to square root it, right?
No, not at all. Because if you square root it, it's more like you are giving it in this form. And also, when you square root it, if you square root it, hey, ya wa bona Shanti, hey, ya o ka runya go re tlhakatlhakantsha ditlhogo wa e bona le wena mos Shanti.
Yeah, I do.
100%. So, all of
Question.
you guys, I know this might be confusing. There's a question coming through.
Sir?
Yebo.
Yes. Can't we, for the r squared, use AD divided by 2? Then it
For
will be
the r
root
squared,
13 squared, then it's 13.
Offense, let me quickly confirm something. You're saying for that, do we not do what? Let me write it down.
We calculated the length of AD as 2 root 13.
SAD 2 root
D.
13.
Yeah,
Oh,
and isn't it
AD.
the diameter, since M is the center? Then
I
we
think
divide that by
honorable
2 to
member is on.
get R.
Honorable member is on to something. Yeah, maybe let me quickly say something here. I don't want to ignore what honorable member is saying, but let's see. We calculated that length, which is AD, and then we also had that. What was the length of AD again?
2 root 13.
2 square root of 13. Okay, 100%. So what honorable member is saying, she's simply saying that we know that this length is actually the diameter. And then since this length is the diameter, so hey, then continue, honorable member. What did you say there?
You
Because
divide
remember,
by 2 to get
r
the
squared is the
radius.
diameter. Okay, we divide it by 2 to get the radius, nay.
Then you square it. It's the same
We
thing.
divide it by 2 to get the radius, which is 13. And then
Yes.
to square it is because he wants us to get r squared. And when you square it, it's more like somehow you remove that square root and it ends up being that. I think this is also a 100% correct, honorable member. This is 100% correct. And I think, Muleboge, this is that time where I would say I like this type of lessons because we learn different approaches. So what I always know is that R, it's actually the radius from there to there. But we did calculate that length and we got it to be 2 root 3 according to honorable member. I remember it was square root of 50. Let's see what square root of 50 is. Let me quickly check. Square root of 50. This length, was it square root of 50 or what was it again?
I also got to the square root of 13, not 50.
Not square root of 50. No. It was square root of 52. Okay, I remember. It was square root of 52, not square root of 50. Let's see, square root of 52. Yes, it's 2 square root of 13. Okay, 100%. So what I was saying was, what we calculate the distance of AD, it's actually the diameter. So we now have to convert this diameter to a radius. And then from the radius, what we do is then to square it to find the d squared, of which it ends up being that. So it's more like whichever suitable way you can work it out, whichever suitable way you can work it out. And this is another way for you to think beyond what we have just done. So thanks very much, honorable member, for that input. You can see that you are still getting it correct. And for that reason, give yourself maximum marks as long as you got that as your final answer. So let's see. I think I need to quickly show you where you get some marks. For correct substitution, give yourself a mark there, where you substituted the X, A, Y, B. Give yourself there, and then lastly, give yourself for the final answer in the requested format. Make sense, Bantu Bagiti?
Yes.
Okay, 100%. Maybe very quickly,
a
let's have a
question.
look. Yes.
Will these videos be posted anywhere?
Oh, yes. It will be posted, Nandi. Let me just quickly confirm. Did you join late or you
I
just want to
wasn't
catch
here.
it up?
I wasn't here when you guys were writing the test. I didn't join to write the test, so.
Oh, okay. No, I see. So just remember to send me an inbox when this lesson is done. I will then direct you to where you can find an introduction to this lesson. So when you watch it, don't start catching up on this one. Start from where we did an introduction and then go lesson by lesson until you get to this one. Nay.
Okay, thank you.
100%. So let's see. I'm going to remove all of these. And then now, let's quickly have a look at the last question. The last question, they're saying, does the point B lie inside, outside, or on the circle in question the previous? Sure, okay. Okay, this is what the question is asking. You've got that point M being the center. So now they're asking if point B, where is B? There is B. Don't have a look at that. But they're just asking if point B lies on the circle, outside the circle, or inside the circle. How are you going to show that, Bantu Bakiti? Anyone would like to suggest? Does B outside, on, or inside? This is a very interesting
So,
question, and these are the type of questions they asked. They ask advice. Yes, honorable member.
so aren't you gonna substitute the values of x of x and y of B into the equation that you got?
Let's try to discuss it further. Why would you do that, honorable member? Why would you do that? Maybe let me write it down so that we can see what we can get out of that. So a very good suggestion there saying, remember we have x minus, what was b? B was 3, yes, squared plus y minus 1, I think, squared is equals to 13. So you have b having the coordinates of -3 and 1. Okay, you tell me, honorable member, what, what, why would you substitute? Can you maybe clarify?
So it's like you substitute in order to like see if the answer that you're gonna get is equal to 13, which is like the r, the radius of the circle. So
Okay,
like
let's
it will
substitute.
tell you if like the point B is outside.
Let's substitute. So what is this? This is -4 squared plus 0 squared 13. This is 16. This is 0. This is what we're getting, honorable member. Then what does it mean?
So 16 is not equal to 13.
Mm-hmm.
So the point B is outside of the circle.
I think honorable member has a point there. I think honorable member has a point there. Another way of thinking about this is what honorable member is trying to. She's trying to prove a point. But let's see if she's correct in saying so. It's more like Moleboge. You just want to know. Remember from here, the center to the circumference is your radius. Yes, from here to there, to the circumference is your radius. Do we know what is our radius?
Yes, sir.
What is it?
13, sir.
13.
Root 13.
Yay. Bantu bakiti 13, it's r squared. But radius, it's a square root of 13. Can you see? So be careful of that. So that means another honorable member of the opposition party can try to calculate the distance from the midpoint to wherever B value is. Then you compare the distances. Wait, what is B? B is -3 and 1. Yes. Then if you get a distance which is bigger than the radius, that means it falls outside. If you get a square root of 13, that means it falls on. But if you get less than that, that means it's inside. So let's check if honorable member was correct. So we're going to say the length or distance of MB is equals to the root of x2 3 minus negative that, it becomes positive 3 squared plus y that minus that squared. What are you getting for this? I think it's square root of this plus this is 9. What is 9 squared? Let's see, 9 squared is 81. So it's more like you're having 81 plus this is 0. So what is square root of 81? Let's see. Square root of 81 is equals to 9. So what does it mean? That means you need to compare 9 and that. So that means from the center there to B, it's actually 9 units. And 9 units, when you compare to the radius, I think
it's not 81. It's square root of 36.
Oh, yes. Yes. I did it as 9 there. So let's see. 3, okay, 6 squared is 30. Yes. So let's see. Now, square root of 36 is 6. Yes. So that means there we are having 6. So that means there it's 6 units. So is 6 greater, less than, or equals to square root of 13? Let me see what square root of 13 is. I think it's small. Yes, square root of 13, it's actually 3 comma 6 whatever. So it's more like we are having 6 which is greater than that. So that means it actually lies outside because it's a bit far by 6 units from M. Whereas on that circle, the radius is just 3.6. I'm not sure if it makes sense, guys. And honorable member of the opposition party, did you say it lies on, in, or outside? What did you say there?
So I said it's outside.
Oh, yes. Honorable member said it's outside. But most importantly, it is not the diameter that you use to make comparison. So that means you won't need to leave it as saying r squared is equals to whatever. It's actually the distance from the center towards that B that you compare with the radius.
Sorry, sir. Can you please just re-explain this part?
Okay. I'm
Sir,
well
can I
aware that
explain
it is. Can you come again, honorable member? What did you say there? Jackie.
Hello, sir. I wanted to explain why B is outside.
Oh, yes, yes. Okay, go for it.
For me, I don't have to do all those things. I don't have to calculate. I just see the center. From the center, I know X is 3. So if X is 3 from the center, it means from the center to the corner of the circle, I think I have 1. So the radius here is 3. From there to the corner here is 1. So minus 3 is behind 1. I don't know how to explain it, just to see minus 3, and from the center here and minus 3, the center minus 3 is outside.
I think honorable member is onto something there. But wait. I'm just not sure of how. Okay. Let's say this is the center there. And then from here, where do I go? Do I go up or left?
Left.
Yes, because from the center to there, it is 300%.
Yes.
And then,
Yes.
and then where do I go?
From there to the here is 3. From the center to B. Where is B? I don't see your B.
B somewhere there.
Yeah.
B
From the
somewhere,
center.
yeah, there.
Yes, B is there. From the center to B. From the center to B is 3.
from the center to B
Is the
is
radius
3,
is 3?
comma something.
Yes.
Yes.
I
Sure.
don't know how to explain it, but I understand it like
No.
that.
Honorable member, you are done. You are
Mm,
done. I think
mm.
it's unfortunate we don't have a metals, but you are done, honorable. I will take it here. Let's just make an assumption that this is my idea. So I'm now stealing it from you, honorable member. Moleboge, I'm not sure if you are still there, honorable member, but I'm going to try and re-explain it so that maybe others can be able to understand it. Let me just try to do a no. Let me use this. Wait, guys, let's now start talking. This is the center M. And we know that whether you go in this direction, that direction is the radius. So from the center there, if you go to the left by that distance, which is what? Let's say 3,6. Do you guys agree that here is 3? We know we calculated the midpoint. So if you go from there to there, it's already 3. Then you add an extra nyana of 0.6. So already from that center there all the way up to somewhere there, this is where your radius ends. And when you compare it with your B, where B has -3, -3 is somewhere here. So that means we already know
Yes.
that the radius it actually does that, and then it
Mm.
does something there. Even though you know most this is handwriting, but you get it. So this point, it actually already we see that it lies outside. I'm not sure if you guys understand the Jackie, is this what you were saying, honorable member?
Yes.
100%. This is also
Even if
a
even if even if you take your ruler, you put your ruler there
yes,
in the center. Put your ruler there,
yes,
you put 3 on the center. You will see when you go to the left, you will see your
mm,
ruler will finish somewhere. You will have 0 here.
somewhere there.
From there, you go again, you will see -3 will be far.
Mm. No, there I
Mm.
agree. The Mashanti, do you now get it, honorable? I think there was an honorable member who
But sir,
requested for it to be re-explained.
sir,
Yes,
the
offense.
question says
Okay.
we must justify with the calculation. So if we do it
Eh,
like this, Jackie, what will our
oh,
calculation be?
what will our calculation look like? Nay, let's see. It should be doable, and this type of thinking the honorable member Jackie has applied. These are the types of questions that you will find at varsity. So let's see. One might say, let's see, the radius of that circle is equals to let's see, what is it? It's already square root of huh? Wait, what did we say is the radius? It's square root of 30, nah, because
Square root of
um
13.
the radius we said is square root of 30, nah.
Mm.
Wait,
So
guys. Um,
we didn't have the
okay.
square root.
Before, Jackie, before I forget, let me quickly finish off this one just to answer honorable member. Let me quickly work out this one and see. We said the radius is square root of 13 years from there to there. This is the radius of the circle. Then let's check what is the distance or length of MB or BM. Will it not be from there up to there, being what? Being 3. Then to get to B, you need to plus by another 3, because B from there all the way up to there. So can you see the total distance from there to there? What is it? It's 6. Then you compare your radius and length BM. So you
Yes.
will notice that the length of BM is actually greater than the radius. 6
Yes.
is greater than square root of that. Yes. The Majekis, are you happy now?
Yes.
I think Jackie, if she says she's happy, then it means I've explained it correctly. I think I wanted to say, who? Who was it? Was it you, Leslie? I forgot. Or Hamisa, was it you who wanted clarity on that one?
No, it wasn't me.
So
Okay,
it
but
was me, but I did get my
mhm,
clarity. But can
mm,
you please repeat that part? If it's a bigger number and then it's
mm,
not inside, if it's inside and then it
mm.
means it's equal to the radius, and then if it's outside, it's a smaller number.
Okay, yeah, no. I think that will summarize it. So let's say if we have a circle, we now go out of that one. If we have a circle and then we know what that radius is, let's say we know the radius is 4, r is 4. So that means if we get a value which is equals to 4, then it means it lies on the circle, on the circle. But if we get a value which is greater than 4, that means it lies outside, somewhere outside. But if we get a value which is less than the radius being 4, that means it's inside. I'm not sure if this one summarizes it, honorable members.
Yes, it does.
100%. Let's see, 2 marks. So that means this question, it wasn't difficult. It's just that you needed to think beyond what you were taught in class. I think this was a very good
Yes.
exercise. So, but now we are done with this question. Is it everyone who's happy then with that one?
Yes.
Okay, I'm just trying to check if we can possibly maybe let's quickly move on to the next one, guys. I'm sure you guys noticed from yesterday's event that all the grade 12s, you don't have time. But in case if you've got too much of schoolwork, um, remember this is being recorded, so you can just make sure that you do your homeworks and then tomorrow catch it up. But very quickly, let's have a look at this one having this diagram and see how far we can go with this one. Maybe after this one, we'll just leave it there. We'll just see how far we can go with this one. Remember, it's just a hand drawing, so it won't be perfect. We're having Q there, we're having P there, S there, angle theta there, and then A, it has this coordinates, -3 and 8. And then we have B there. We have that point there being C, 6 and 1. We have that being T. I'm going to try and make myself here and try to see if I can answer these questions without going through. But maybe let me do. A, B, C, D is a rhombus having those coordinates. The diagonals of A, B, C, D bisect each other at M. The point E, where's E? Okay, there's E. lies on BC. Okay. So let's see if I calculate the coordinates of M. So can you see M is, I just need 2 points. So let's see. M is going to, we know the formula. So let's say this is, that one is x1, -3 plus x2 being 5 over that. And then what is y2 is that plus -4. So remember, guys, I'm doing this very quickly because we have done all of this many times. So we try not to waste some time. So let's see. What is 5 minus that? Is it not 2? 2 over 2 is 1. What is this minus that? Is it not 4? 4 over that, that is... Do you guys agree with me on that one? I think all of you do agree with me on that one. Do you guys not agree with me on that one?
I agree. I got the same.
Yeah. So calculate A. Give yourself a mark for correct substitution and final answer. Only 2 marks. So calculate the gradient of BC. Where is B? Where is C? There's B there. Calculate. Oh, no. I withdraw that. It's not complicated. Remember, line C, E, and B are collinear. How do I know? Because they said point E, it lies on BC. So I can use this and that to calculate the gradient of that line. So let's see. Obviously, we know the formula. Let's not waste time. What is y2? It's -4 minus y1. It is that over what is x2? That and that. What are these? Is it not -5? What is this? Is it not -1? And then now, are we not having 5? Do you guys agree with me on that one?
Yes, sir.
Gradient of BC is equals to 5. So can you see? They are starting nicely with this is equal. Let's see where it's going to get difficult. So determine the equation of the line AD. Where is AD? There is A, there is D. In the form y is equals to mx plus c. AD. No, it has to be easy because we already have 2 things, the 2 points. Why not just calculate the gradient and then from there we can just substitute there. Do you guys
We
not
have
agree
the
with me on that
gradient.
one?
But we have the gradients. Aren't they parallel to each other? Or don't they share like the same gradients as well?
Oh, yes. You know, in my mind, I'm thinking AC. Yes. So we have y is equals to, what is that? It's 5x plus c. Let's choose the easiest. Oh, we are forced to use that point. I don't think we've got the coordinates of D. So let's see. We have 8, which is equals to 5 into that plus c. This is 15. You take it to the other side, I think is 20. Then you have extra 3 from that 8, which is... So it seems like we're having y, which is equals to 5x plus 23 for that. I'm not sure. I'm a bit fast today, guys, and I hope you understand the reason to that. But I'm pretty much sure that for those of you guys who started with me when we did intro, all of this, they do make sense, most Bantu Bagit.
Yes.
Yes, sir.
Okay, 100%. So how many marks? 3 marks. So let's see. For you to know the gradients are equal, give yourself a mark. For correct substitution there, give yourself a mark, and then last mark on the formula. So now let's move on to the next question. So let's see what they say on that next question. What are they saying? They say determine the size of theta. That is, they want theta that is in triangle BAC. So it's more like we're trying to calculate that angle A. And there's that angle. Yes. How are we going to work out that one, Bantu Bakiti? Anyone who would like to suggest how are we going to work out that one?
So I'm gonna try. I'm not correct.
Yes.
So sir, I suggest that we use the gradient of AC to get the angle. Let me check. The angle which is inclined by the y-axis and the line AC.
Wait. I think let me try to show you that easiest way, and then from there, whichever method that you used, then you check if it takes us to the final answer. I think this is going to be the easiest way. I just realized we know what that is. Hey, do we know what B is? I don't think we know what B is. But if we knew what B is, so let's say we will try to see if we can find that B. And if we find that B, you can see that we actually have a right angled triangle, because here where they bisect, they form that 90 degree. I'm not sure if you guys agree. Then if we can calculate that length or distance and also have that, we can use trig ratios to calculate that angle theta. I'm not sure if it makes sense, guys. I'm not sure if it makes sense what I'm trying to explain there.
It does make sense.
It does make sense.
But the question is, how are we going to... Okay, in the meantime, let's calculate the distance of AM. That one we can easily work it out, because we know that x2, we can say it's m, being 1 minus that one being negative 3 close squared, plus y being 2 there, minus 8 squared. Then, can you guys see what this is? 4 squared is 16. This is 6 squared. So what answer are we getting there? What is that one? I think we got that one. Is it 32?
36, sir.
Oh, yes, 36. Then let's see. Square root of 16 plus 36 is 2 the root of 13. So that means here we have 2 the root of 13. Yes. So is there another way in which we can calculate something there, guys?
So,
Mm-hmm.
okay, so you know that line AC bisects line okay, sir. No, I thought we
You
had
withdraw.
Yes, sir.
Hey, withdraw, honorable member. Withdraw, and let's strategize. Let's strategize. But the question is, this E, is it the midpoint of BC, where we can use the midpoint of the midpoint formula to calculate B? Did they tell on the statement if E is the midpoint? No, they just said it lies. They just said it lies
Sir,
on.
I got another suggestion. Okay.
Mm.
So, so you know that the diagonals of the rhombus are equal.
100%.
So, sir,
100%.
the distance from AM is equal to the distance of MB.
I'm telling
So,
you,
sir, you can
amadlozi
find.
ami ayavuma. I didn't even have to say vumani bo, but already ayavuma. And I'm telling you, if Moleboge is on the line, she will confirm to say, when it comes to diagonal, Moleboge, I won't say diagonal, but I will say it. The distance of the diagonal lines, are they not equal, Moleboge? Hey, Moleboge, are you sure? You are not watching the river there. I'm suspecting.
No, I'm not watching the river.
But do you confirm?
Or I confirm what?
Or a distance at the diagonal lines is equal?
Yes.
Because I do remember very well, we had a similar lesson where we had something of this name. But wait,
Yes, I remember
uh,
that because I confirm. I confirm you are correct. We've done it. Previous lessons,
I just can't remember
previous
when,
question.
but I'm sure of that one.
Even the
But
last
wait,
question it had it.
I see
Think
Jackie's on the line. Jackie, are you saying something there? I can't hear Jackie, but everyone, do you understand? Shanti, are you sure you understand what we have done
No,
there?
sir.
Mm-hmm.
Yeah,
sir,
something.
sir,
Mm-hmm.
I disagree a little bit because
Yes.
according to the properties of a rhombus and not a
Mm.
square, line MB is equals to MD and AM
Line.
is equals to MC, but they're not all equal to each other.
Wait, you're saying line what? What did you say there, honorable member? You said line what?
Is equals to CM,
Which line?
but BM, line
You.
BM
Mm-hmm.
is equals to DM
Yes. Yes.
and
Mm-hmm.
AM is equals to CM, but they are all not equal to each other.
But they are not all equal. Okay. I think I get what honorable member is saying there, which is a good debate, which means we will need to understand the properties of a rhombus. So what honorable member is saying, Moleboge, is that not always you might find the lengths of the diagonals being equal. For example, this one, yes, it's supposed to be a straight thing. So honorable member is correct there to say this is the no, it's not the midpoint. It's not the midpoint, but she's just saying chances are from this point to there, or maybe let me say from there to there, it's equals to from there to there. But it doesn't mean from there to there is equals to from there to there. Okay, this is something else. But from what she's saying, maybe let me do it this way. I just want to make sure that I explain what honorable member. So honorable member is saying this is equals to that, and this is equals to that, but it doesn't mean from here to there. Ish, yeah, no. Let me try to be realistic. But I'm not sure if you guys get the honorable member's point. She's saying from there to there, it's equals to there, but it doesn't mean from there to there. Since it's equals to there, then it means from there to there, it's equals to there. That's what honorable member is saying. But the question is, with regards to a rhombus, what do we know about rhombus? when we are having a rhombus, do we have from there to there being equals to from there to there, there to there being equal to there, there to there? This is debatable, but I can tell you now, with a rhombus, they are. I'm not sure if there's someone to back me up on that one.
Sir, can I say something?
Yes.
For me, I know that a rhomba is a quadrilateral. So it's only the opposite sides are the same. Not all the sides are the same, only the opposite.
That's what I know too, because it's not a square.
Sir, can I please talk? Sir,
Yes.
with a rhombus has got 4 equal sides. Okay, sir. And the diagonals, they meet at a 90 degree angle. Yes, sir. So, sir, since the what do you call this? The sides are equal. The lines where the diagonals bisect each other, the lines they are gonna be equal.
That's correct. So it's more like with a rhombus, this is parallel to that, and this is parallel to that, and at the same time, this length is equals to that length is equals to that. That is why that will be equals to that. So I think it was Kabelo who was saying, Kabelo, will I be summarizing it if I say rhombus is a square but at an angle? For example, this is a square. If you tilt it, then maybe it takes a certain angle. It is still a square, but at an angle. Then we call it rhombus. Did I summarize it?
Can I say something about the properties of the rhombus?
Lwandiswa, you are recognized, honorable member.
Yes, sir. So the diagonals are perpendicular and they bisect each other. So what's I think Cabello or Offense said that AM like AM is equal to MC and then BM is equal to MD. That's what's the property. Yes, sir. So, sir, AM is not equal to MP, so we cannot use 2 root 13 for BM. You have to calculate the coordinates of B and then calculate the distance from B to M because it's not the same AM and PM because the diagonals are perpendicular and bisect each other.
Okay, here comes a question. Do we say they are not equal based on the fact that they are diagonals which form 90 degrees, or on what basis are you saying they are not equal?
They are perpendicular, sir.
So which is why you say they are not equal?
Yes.
Okay, let me show you something also. This is a square. This is a square. This side is 2, this side is 2, this side is also 2, this side is also 2. This is a square. And I'm having this line and also I'm having that line. So these lines, they form 90 degree there. That's where they intersect. So would you still use the same reason to say because they form 90 degrees there, therefore from there to there it's only equals to there to there and not there to there? It's more like I'm trying to say it won't serve as a reason to say they are not equal. It's more like you are telling the truth, but it doesn't mean they are not equal. I'm just not sure how to explain this one. Yes, maybe someone dive in, but offense, wait for Kabelo to make a point.
Okay, sir. Since the rhombus with the diagonals that bisect each other share the same angle. No, not the same angle, but the same size
The
of
same
an
midpoint.
angle.
Oh, okay.
Yeah.
Yes.
And the same size of an angle, the same size of the side, like distance of the side. The diagonals like bisected, that equals as like DM is equal to BM. Okay. And it's
BM.
also equal to AM. Yes, sir. And also to MC.
Which is what I agree with on that one. I'm just not sure because the other honorable members, what you are saying, it is correct to say these lines, they intersect, the diagonal lines, they intersect there and they form 90 degrees. I think it's us only not being sure whether this and that are equal. But I'm telling you, when it comes to a rhombus, that's why I was saying rhombus is like a shape of a square, whereby this side is equals to that, is equals to that, is equals to that. But this square, you just tilt it, and when you tilt it, it now looks at an angle. Yeah, it now looks at an angle, but it's still a square. So it's more like on this square, if you do that and you do that, it forms 90 degrees, 90 degrees, 90 degrees, 90 degrees. Meaning from here to there, it's equals to there, still equals to there, still equals to there. So it's more like you are having four triangles. This one, that one, this one, and that one. So now you just tilt it. If you tilt it, then it looks something like this. Can you see? You still have that 90, that 90, that 90, that 90. I'm not sure if it makes sense, guys. That's what I was saying. Offense or Kabelo. Did I summarize it when I explained rhombus in that manner there? I'm just not
So
sure if
I'll
honorable
convince
members.
you that a rhombus is not a square after class. But for now, I have a solution that will accommodate us all with answering the question.
Maybe I'm also a wrong offense because remember, as an individual, there's a way in which you understand things. Maybe for the sake of everyone, explain everything because I might also learn something from your explanation so that we all learn from whatever that you'll be saying.
Sir, can we solve this one? Then I'll explain afterwards. I've found another solution. We can get the coordinate of V with the gradient. Then from there on, I even forgot where to go.
100%. 100%. Honorable member has got a point there.
And M we can also get using the coordinate of AC because it's the midpoint of AC.
Yes, even let's see BM. With that BM, we will be able to
then from there on we
confirm.
can calculate DM, which is equal to BM. Then we use the sine
whatever.
rules. Yeah.
But
Yeah.
yes, honorable member has a point there. But after this, let's make sure to remember that explanation. And I think this one is going to confirm whether from there to there it's equals to from there to there. So let's quickly, we know most the gradient is 5. That one we know. We know the gradient is 5, which is y2 minus y1 over x2 minus But wait, the gradient, are we going to survive? Because we will end up having a simultaneous equation there. Hmm? Offense.
Sir?
Yes, that gradient formula. How are we going to then substitute that one?
So I'm not always sure about my shortcuts if they're correct. But
Yes, honorable member, even though, let's see, we know the gradient is 5, it's equal to, let's say this is y2, x and y of b and that. So let's see, we know the gradient of that line is equals to 5. Then you can still say 5 is equals to, you can maybe use these 2 points, even though it seems like we're going to have a small, okay, y2 being 1 minus y at b over x2 being that minus y at x at a. Then we can say this is equation number 1. And then we can still do the same and now calculate the gradient. This was the gradient of a BE from there to there. And then now let's calculate the gradient of from there to there, being BC. So that means we know the gradient of BC still is 5, which is equals to y2. We can say that negative 4 minus y at b over this one being. I'm hoping that you guys are following on that one, even though it seems like it's going to be lengthy. But what I like about this, it will confirm if those lengths are equal. And then let's see. What you do, you can just cross multiply. Then you are having 5 into what is it? 6 minus x at a, which is equals to y minus 1 minus y at b. And then you can also do the same.
The gradient of BE.
Wait, what did you say there, honorable member?
Why are we calculating the gradient of BE?
Let me see. BE. What? Oh, no. We are not calculating the gradient of BE. We already know the gradient of BE. We just want the coordinates of B, but using that gradient that we know. Maybe let me see how far. But did I answer you? Who was speaking there? Was it you, Offense?
And yes, you answered me.
Okay, so let's see. For this one, you do the same. So you have 5 into 5 minus x at a. So this is another type of thinking that you will get at varsity, guys. They just train your thinking there. So it's more like simultaneous type of a question. It's not only given. You can also create it based on the information that you have. But let's see how far we can go with this one. We just use that to calculate the B, that. So let's make maybe something the subject, maybe B, the subject of the formula. So that means you're going to have, if we make it from there, you're going to have a 5. Let's say this times that. What is that? Let's see. A 5 times 6, it's equals to 30. Minus that times that is equals to 5x of a. And then you take these to the other side. Or maybe let me just say that as it is. And then I will say let's take this to the other side so that is positive y at b, which is equals to, we have 1, you take this to the other side is minus 30, this to the other side is 5, x at a. So these two, when you work them out together, it's more like you're having y at b, which is equals to, this is negative 29. So it's more like you're having 5x at a minus 29. So this one becomes our equation number 1. We do the same for this one. I'm not sure if you guys understand what I'm doing there, but if you don't, can you maybe indicate? But I think we are all on the same page on that one. This times this is 25. Just check if I'm making mistakes in terms of calculations, but let's see how far we are going to end with that one. Then we have y at b. So let's try to make it subject of the formula. We take this to the other side is y at b, which is equals to, this to the other side, it becomes positive 5x at a, and then that one, it makes it minus 24. Then we have this as our equation number 2. And then equation number 1, we have it as, yes.
It's negative 4 minus yb.
Did I make a mistake somewhere? Let's see.
Yes, it's negative 4.
Negative 4.
Yes.
This one, oh yes, negative 4. Where did I make a mistake? Oh, I copied.
Took the 1 minus yp from top.
This one.
Yes, sir.
Okay, wait. Let me retrace. Oh, this times that is that 25. This time is that one. And then yes. Thanks, honorable member. But it's negative 4. Yes, it's negative 4. So that means you take this to the other side is positive. This to the other side, it is that positive. This to the other side. So it's more like you are having a negative 4 minus 25, which is negative 29. Yes, which is that. Yeah, I think I'm correct in doing that. And then here we are having 1. Just says I'm thinking I lost everyone here, but let's see. This is going to be equated to that. It's more like 5x at a minus 29. It's equals to that one being 5 that minus 29 also. You take this to the other side, then it won't work, because already you're having 0, this to the other side is 29, and then that it also gives you just offense. It seems like it failed this one of using the gradient. It failed. I'm not sure if you are able to notice, honorable member, it failed. We won't prove using that. And I don't think I made a mistake when I was trying to simplify. But in the meantime, what did you say, offense, regarding a rhombus? Or what were you saying there regarding the properties?
A rhombus, all sides, the outsides are equal in length, and they are parallel. The opposite angles are also equal.
Yes.
They bisect at 90 degrees.
100%.
And listen to the properties of a square regarding the diagonals. The diagonals are equal and bisect at 90 degrees, but not the diagonals of a rhombus, because it's skewed, it stretches the length of each diagonal side. Yeah.
Why am I suspecting it's almost the same? Okay, let's say this is a square, ne? This side is equals to that side, and this side, all the sides are equal, isn't it? Of a square. All the sides of a square are equal, and also the diagonal lines, they intersect and they form an angle of 90 degrees there. Can you see? So already it means from here to there is equals to from there to there, and from there to there is equals to from there to there. So what I was saying is that since this is a square, I wanted honorable members to just remember that. Let's say or take a rhombus being a square, which is just tilted, which is like that. Yes, let me not redraw it, but put it like that. At an angle, it still has the properties of a square, but it's at an angle. And I think, I'm not sure if it was Kabelo, what you just said, it confirms that from there to there, they are equal. From there to there, it's equals to from there to there. Based on what you said when you're saying all the sides are equal, and this is parallel to that, and they form a 90 degree in the middle. Because all this calculation that we were doing here, it was to try prove that this length from there to there is going to be equals to a, what is it? No, we wanted to calculate the coordinates of B, so that we're going to say the length from M to B, it's equals to from M to A. That's why we wanted to calculate the coordinates of B.
Sorry, sir.
But
I'm so sorry to
yes,
interrupt. But I believe we all like enjoy eating, ne? So, sir, my example is gonna be with like a piece of bread, a sandwich.
Yeah.
You cut holy triangles. Okay. You cut holy triangles, and the bread. Let's assume the bread sides are all equal.
A slice of bread, ne?
Yes, sir.
Let's do that.
So, sir, you cut like holy triangles, like diagonal lines.
Yes, A, B, C, D. Then you have that from there to there. You have that from there to there.
Okay, sir. So, sir, we assuming that all the sides are equal.
Okay, wait. Okay, so according to rhombus, we don't assume, but they are equal. According to the properties of rhombus, we don't assume, they are equal. Before you continue, Kabelo, offense, do you confirm this one based on the properties that you got? To say all the sides are equal when it comes to a rhombus. Sure, it seems like offense is gone. Okay.
Sir?
Yes, sir.
Yes, offense. Kabelo.
Yes, and I send you a picture of.
Okay, 100%. I'll also share it in the group. So, Kabelo, this is what I was saying. With rhombus, we don't assume, but they are equal. All these sides are equal as far as rhombus is concerned. Then, oh, okay. No, I see. Okay. Okay, let's assume all the sides are equal. Yes.
So, sir, cutting the bread, when you put all the triangles, like the holy triangles on top of each other, they're exactly the same size.
100%, I agree. So, honorable member is saying when we look at that top triangle and you also take this one, this is what you are saying, Mos.
Yes, sir.
Yes. Continue. So you're saying if we put this and we put it there, and we also take this one, it's going to fit in there. This one is also going to fit in there. This one is also going to fit in there in the same size. Yes, I agree.
So, sir, since we got, as what I did say, since we got angles that are equal, like the angles that are diagonal are equal, and they all share the same length of the size. They are equal, sir. They are equal. And referring to like what you said, a rhombus is basically a square tilted like at an angle.
Yes. Honorable member is onto something.
We know that both a rhombus and a square are parallelograms and quadrilateral. So which means that they have 4 sides with parallel and opposite sides. The only difference is like the angle, which is like, which it is tilted, or which way, wherever you be like seeing it. So, sir, where the diagonals are perpendicular, it is equal, sir.
Where the diagonals are perpendicular.
The research does also prove it. I'll send you a picture, sir, of like the similarities of a rhombus and a square.
Okay. This is what honorable member is saying in the shortest way. I'm telling you guys, if we already agree that this is a square, we already know this is what a 90 degree. This is 90 degree. This is 90 degree. Also, this is 90 degree. This is a square. If you tilt it, it now becomes a rhombus. So that's what I try to explain, to say, remember a square which is tilted at an angle, nothing changes. But now, you see, when you join this and that, and you also join this and that, I'm sure you already noticed that this is actually half of 90, which is 45. This is also 45. 45, 45. Everything is 45, 45, 45, 45. So it's more like with what honorable member is saying there, with good reasoning, already she can just say this is 45 degrees. Or if we need to calculate based on what we were saying here, because this is not done. We were stuck here because we wanted to prove that that distance from there to there is equal to the distance from there to there. That's why we tried with using that gradient formula, but we couldn't succeed. But in short, this is where you will now use the tan angle, which is equals to opposite over adjacent. What is opposite? This is the side opposite to the angle, which is root 2 root of, and then this is adjacent, which is that. This divided by that, it's equals to 1. So it's more like you are having a angle which is equals to second function of 1. What is second function of 1? Let's check if it's going to give us 45. What are we getting there, guys? Guys,
Sir?
Yes. What are you getting? It's 1. I think second function of tan 1 is it's 45. It's 45. Are you guys not getting 45?
Yes,
It's
sir, it
45.
is 45.
Yes. It's 45. So that means you've got two ways of doing it. So that means you will need good reasoning, using your understanding of Euclidean geometry. It's unfortunate on my side, I haven't done Euclidean geometry, so I'm not really good with the reasonings and everything. That is why I indicated we're going to be having a new tutor who does this full time at a private school. So they will take you through what is it? That chapter for Euclidean geometry and any other chapters which are not included during my time. But most importantly, with my little knowledge, I do know very well that when it comes to a rhombus, you are having too many things being equal there. And also, let me say, for example, for me, if I was in matric or if I was writing this question paper, I was going to do it this way. And I wouldn't do it this way because I wasn't going to give proper reasons. But for someone like, let's say, Kabelo, based on your understanding on Euclidean geometry, you were still going to get it correct. If, for example, you were able to prove that rhombus, whatever the sides being parallel and equal, and I'm sure if we do this, somehow we might even be having alternating angles there, or otherwise, if they are not, yes, if we already know this angle is 45, and then we have that line, I think you can be saying you also have that one. So I think it forms that kind of a Z thing. Is it a Z thing? But what is that reason where you say this angle, it is equals to that angle? Yes, because you have this being equals to that. I know there's that reason. Something alternating whatever. I'm not sure if it makes sense what I'm trying to explain there, honorable members.
It does make sense, sir.
It does make sense.
One thing for sure, I might not be explaining it in the best way, but what I know is that this angle is equals to that. So with your reasoning, you can still take a shortcut of giving reasons, and then from there, you indicate that that angle is actually equals to 45, and then that's how you score yourself 6 marks for that question. But this is what I'm going to say. If you performed calculations and you got that to be 45, give yourself maximum marks on that one. But if you did it this way, for you to calculate that distance, you will somehow score your marks there. And then also, let's see, for you to give that reason to say this is equals to that, give yourself marks there also. And for the calculation of this angle using tan, give yourself marks also there. And that's how you score yourself 6 marks for this one. So I think
you referring
let's
to
leave it. Moleboge, 5.4.
I was just asking, were you referring to co-interior angles or corresponding angles, or no alternative angles?
Something of that nature, Moleboge. It's unfortunate. I won't be able to confirm because
I think
I completely haven't done that. But I'm sure you guys know what I was talking about there.
I think
Something
no
of that nature.
alternative angles. Yeah. Okay.
Yes, it has to be alternating angles. This is what I wanted to say. The first question that we did, it was out of what? I think it was out of 20. So via inbox, you will tell how much you got out of 20. And then for this one is out of 13. You will also tell how much you got. On our next lesson, we will see if we can manage to do that last question and still do something else, or we'll just focus on that. Then you will tell how much you got. I think on this next lesson when we do this, that's when we'll do a total of everything. But for now, via inbox, tell how much you got out of 20 for this one, how much you got out of 13 for this one. If you like, you can still give a percentage for this one and also a percentage for this question, because you just say whatever divided by that times 100, it gives you that by that 100, it gives you a percentage. Did you guys understand what is expected of you,
No,
those who managed to run?
So I did understand, but I got the class late. I think you were done with the other one. I got you on the second one. So should I mark the second one and send the results and
Okay, no, I
watch it
see.
tomorrow? Or
Yes. No, in your case, you can send for this one, and then when you catch up, you work it out for this part, and then you send afterwards. But everyone else, that one. Let's see. The code for today. What will be the code? I think you can just use the coordinates of E being 6 and 1. Yeah, let's maybe just comment that as the code for today. Guys, I'm about to sign out. Sure, yeah, no, we have gone. We have okay, but guys, are you okay that side before I sign out? At least we had a productive lesson. Whatever honorable members shared via inbox, I'll also share with everyone. But otherwise, anyone who's got a question, or do you guys allow me to sign out?
No question on my side.
No question from Hamisa's side. So today's lesson was quick, and I did not also prepare for this lesson. So these are the types of lessons where I don't prepare. And the reason to that is because it's more like I want to try and go through what you went through, not knowing what to expect. You just start thinking as you see the question. So that's why my lesson was all over. It's based on that. So for all the tests that you write, I don't prepare for those, but we do the corrections and see if in the end all of us can manage to get the fun. But Mzozozo, do you allow me to sign out, honorable member?
I was thinking we are cross-nighting, sir. You can sign out, say thank you.
Hey, guys, my name is Desmond, and I'm out.